So I thought I'd just share how I would analyze some of these Jeopardy problems or solve them. So this is Phasors, complex numbers for 100, and we'll just work our way up. First, one thing to know is just always being able to turn our terms, our words, into variables that are on the formula sheet. So there is period, which is T. Here's frequency, which is F. This is VM. A word for that would be amplitude. And another word for V peak would be the peak to peak value, the peak to peak voltage. The amplitude could also be called just the peak, V peak. That's actually what it says on your formula sheet, V peak. So the waveform's period, we can look at it from where it crosses up through the x-axis to where it crosses up through the axis again. How long does it take to go through one cycle? One cycle takes from 0 to 0.4, so we could say t is equal to 0.4 seconds. In engineering units, that would actually be 400 milliseconds. The frequency on the formula sheet says it's 1 over t. So 1 over 0.4 would give us 2.5 hertz. The frequency is the inverse of t. T is also the inverse of the frequency. If I wanted to measure it at a different place, say that it didn't cross through 0, it could also be measured anywhere. Here's where it's crossing up through the x-axis and up again. 1.2 minus 0.8 gives me 0.4. That is still t, and that's because that's how often it's changing, going through one cycle. Vm is the amplitude. It's right there. That is Vm. It's how high is it above 0. And the peak to peak is from 8 to -8, so it's 16 volts. You could also say 2 times 8 volts is 16 volts, and that is V peak to peak. All right, let's look now. We'll clear this. Go back to 200, right? A sine wave has a value of 50 volts when its alpha is 150. Now, what is the alpha? It is showing us that it is inside this equation, but on your formula sheet, the equation just says omega t. But we could probably just plug this in right here and get what we need to know, which is that E, as a function of time, is that equation. Well, let's plug in our value. E at 150, if we're treating A, or the alpha, as the variable, then we have E, the magnitude, the amplitude is another word, sine of 150. And at that time, its value is 50 volts. So whenever we're at 150 degrees right here, right there, is where it is at 150. We can solve for that, the amplitude, and plug in the 50 volts and divide it by that sine right there, sine of 150, and our answer is 100 volts. We'll go back to the 300 level Jeopardy, clear that out. Once again, let's turn these words into variables. We have a frequency right here that is F. It has an instantaneous value of 100 volts when it's at 1.25 milliseconds. So in our basic equation, E as a function of time is equal to the amplitude sine 2 pi f t. Note this 2 pi f is the same as omega. As we had earlier, that is the alpha. And then it's plus or minus theta in the full equation. But right here, it's crossing up through the x-axis at 0. So this is actually 0. Now, if we are looking at the description, it says that E at 1.25 milliseconds is equal to 100 volts. And what we're going to find is the full sine equation, which means we are going to need to solve for this again. And then we're multiplying the sine. What is inside the sine? It's still 2 pi. The F is 100. And the T is 1.25 milliseconds. What we get there is E as the amplitude. We divide 100 by all of this term, sine 2 pi 100, 1.25 milliseconds, and we get 141 volts. So we must find the sine equation. Let's just plug in the terms that we've now solved for. Oops. Sine, in that we still have 2 pi f, 2 pi 100, you could say 200 pi, t, because it's our variable, and we already determined that it was 0. So E as a function of time is equal to, right there, and if we're writing the full equation, I'll just go ahead and plug in the 141 that we solved for, 141 volts. So now we just plug in 2.5 right there into the T, and E at 2.5 milliseconds is also 141 volts.